morning, students. Myself, Dr. Eustace Russell, working as Assistant Professor in the Department of Mechatronics Engineering at Sri Muthukumaran Institute of Technology. So far, we are seeing this subject called Engineering Mechanics, subject code ME25C02 under the regulation of 2025. Earlier, we have completed part 1 of Unit 2, that is Statics of Rigid Bodies. We have seen the basic concept of movement, how we have to take the moment calculation. In vector form also we have seen along I, Y and K components. With some formulas also we have seen. Today we are going to go through the similar topic but different ways we will see that. The same moment we will once again we will look onto that, and some problems also we will look onto that. Moment of a couple. Already in the part 1 we have seen some introduction part. Again it a recall of this, the same concept which I took here, that is moment of a couple. Moment produced by two equal, opposite and non-collinear forces is called a couple. I will repeat once again. Moment produced by two equal, opposite. See this diagram. Two forces are there, right? One is minus F, another one is plus F, right? Opposite, but it should be very equal, but it is opposite. Non-collinear forces. Non-collinear. It won't act in a same line. Different direction it will act. So that is called non-collinear. It's called a couple. Now we will see that magnitude of the combined moment of the two forces about point O is given by M equal to F into A plus D minus FA equal to FD, because FA will get cancelled. Then along with that, M equal to RA into F plus RB into minus F. Then RA minus RB into F only we have to take, because F is the common term. Then R into F. Finally, we are writing FD. That is also equal to FD. Then here this side, movement vector of the couple is independent of the choice of the origin of the coordinate axis. Is independent of the choice of the origin of the coordinate axis. It is a free vector that can be applied at any point with the same effect. It is a free vector only. At any point we can apply without any effect. That is one important point here. Here various moment of couple it is mentioned over here. You can see the diagram. See, one force is there and one perpendicular distance that is also acting D. Moment is nothing but force into perpendicular distance. You are going to see that also. Then the second diagram below that, two forces are there, minus F1, then D1 is the distance. Then another one, F2, then D2 is the distance. Two couples will have equal moments if F1 D1 equal to F2 D2. Two couples lie in parallel planes. Two couples having the same sense are the tendency to cause rotation in the same direction. Two couples means one will be one side, because last side we can see the forces that is acting on two sides will produce a couple, will form a rotary motion to cause a rotation in the same direction. See in the first sketch we can see that F is acting over there, okay. Then again minus F is acting towards the object. Then it form the movement will create a rotary motion automatically. Here also the same sketch, second diagram. All are similar to one another. Finally, the movement we are getting in a rotational motion. That is important. See, all the sketches we have the rotation center point movement, we will have a rotary motion. Then addition of couples. Consider two intersecting planes P1 and P2 with each containing a couple P1 and P2. Here these two are planes, intersecting planes, and R into F1, then R into F2. Two things we have to. R into F1, R into F2 in plane 2. Resultant of the vectors also form a couple. How it will form a couple? M equal to R into R. R into R. What is R? The summation of both forces, F1 plus F2. Then by Varegran's theorem, what is Varegran's theorem? The sum of moment of all forces about one particular point equal to sum of the moment of the resultant force about the same point. That is the definition we already studied. So moment equal to R into F1 plus R into F2. Summation of all moment of all forces equal to M1 plus M2, because already we declared M1 equal to R into F1, M2 equal to R into F2. That's why we are substituting here. So sum of two couples is also a couple that is equal to the vector sum of the two couples. Then couple vectors. Couple can be represented by a vector with magnitude and direction equal to the moment of the couple. Couple can be represented by a vector with magnitude and direction. That is important. It's having a magnitude and direction equal to the moment of the couple. Couple vectors obey the law of addition of vectors. Already we have seen the introduction part. Addition of vectors also we have seen. The couple vectors will follow the laws of this addition vectors. Couple vectors are free vectors. The point of application is not a significant. Coupled vectors are free vectors only. Point of application is not a significant one. Then coupled vectors may be resolved into component vectors. Component vectors. We can see component vectors. Here in equivalent systems, here various applications are given, students. First application in the left hand side, the topmost upper side of the left hand side, we can see BA, one man that is holding a rod, F that is force that is acting towards the direction, and B is the man holding that point, that is B. Okay. So in this, the second one, the forces will acting at B, opposite and backward direction. So both will get cancelled to form only one force. That is, we already studied in principle of transferability. The same concept again it is utilized here. Now, second diagram, in order to form a couple, what you are doing, only one force is there. In order to balance, what you have to do means, in the B point, we have to add one upward force and the downward force. Finally, if you form a loop, what will happen? In the left hand side, downward arrow will come. Then, in the right hand side of the downward force and the left hand side of the upward force, together will create a couple. That is called M equal to FD. That's why we wrote there. The same concept written in the diagram also. The circles they have marked. No? The same what I told, that there is represent in the diagram. Another one thing, in the traffic signals you might have seen that light, hanging lights. It is fixed in the rod, but according to the gravity of the force, where the weight of the lamp will act towards the road only. That's why W1, W2. With the distance from the pillar of the lamp column, that is D1, D2. What you can write? W1 plus W2 is the weight. Then if you are taking moment, what will come? That is, what will come? W1 into D1 plus W2 into D2. Force into perpendicular distance. Now another one, same thing. We are going to, one man is holding a long scale. That is F1, F2, various forces are there. What is the resultant force means? Adding of all the forces. Now applying Varegran's theorem, we can find FRD equal to F1 D1 plus F2 D2 plus F3 D3. Moment of the resultant force about the grip must be equal to moment of the forces about the grip. Equilibrium of a body is the condition in which resultant of all the forces acting on the body is zero. This is the important definition for equilibrium condition. The resultant of all forces acting on a body should be equal to zero. That is important one. Then this slide represents one problem, basic simple problem only. Compute the resultant force and the resultant couple at point A. Here one rod that is given, one square bar or one rod rectangular bar. What the various forces are acting? 150J minus 600J plus 100J, sorry 100J minus 250J, and various distance also it is given. How to find out the resultant? Adding all the forces. If it is upward means positive, downward means negative. The same concept what you discussed in the first unit. Finally, you will get minus 600 Newton J. Then you are applying Weygran's theorem, force into distance, that is summation of R into F. The same concept. We have to multiply with the resultant of all the forces. That is important. All the forces in sense means distances. Distance. So this is the R now. R. Then we have to multiply with the distances. What are the distance you will get? 1.6 I into minus 600J. Because a point one force is there, no distance is there, but automatically that will get cancelled. So remaining part only it will come 100J and minus 250J. Upon calculation you will get minus 1880 Newton meter. Another one problem. Find the equilibrium equivalent force coupled system at point B based on the force coupled system at A. The force is unchanged by the movement of force coupled system from A to B. Now what is our R here? Minus 600 Newton I component. Couplet B is equal to the moment about B of the force coupled system found at A, point A. Now we can write MR B equal to MR A plus R AB into R. Upon calculation we have the value minus 800 K plus minus inside the bracket 4.8 I into minus 600 J. Finally you will getting 1000 Newton meter. Along the K component you have to mention. So this is the reference which I took to prepare this contents. Kindly go through the references. Kindly go through the slide also once more. Thank you students. Thank you for the kind attention. Please subscribe the channel and share this video to your friends. So we will see in the upcoming lecture videos. Thank you.